Hey, I would like to take a few minutes and talk to you about pages 29 to 31. Today we'll be comparing rate of change, and that will be our goal as well. I can compare rate of change. So rate of change is another way of saying slope. And so what I've done up here is I found different images to kind of refresh your memory on what slope is. So it's the vertical change over the horizontal change, or you could say rise over run. Another way of saying it is change in y over change in x. And this should look a lot like what you did yesterday in the Google slideshow. Again, change in y over change in x. So when you are determining the rate of change in ordered pairs, it's the change in y. So how much does it change from 4 to 16? It changed 12. And then how much does it change from 2 to 6? It changes 4. So the y's go on top, rise over run, y's over x. So 4 to 16, it changed 12. From 2 to 6, it changed 4. So the slope would be 12 over 4, which when you divide is 3. So whether it looks like ordered pairs or if it looks like a table, you can do the same thing. Here, change in y is 4, change in x is 4. 4 over 4 would be 1. So hopefully that will help you on the front page. And then we're going to start thinking about comparing two different ones. So Adam sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. So that's his rate of change, 7 signs every 2 hours. If you simplify it, that would mean he could make 3.5 signs every 1 hour. So if you make it a unit rate, sometimes that makes it easier. His friend Harrison helps him make signs at the rate below. And so Harrison's are down here at the table. So then you can say change in y is 15, change of x is 4. And then if you do 15 divide by 4, you would get 3.75. And so Harrison's making 3.75 signs per hour, and Adam's making 3.5 signs per hour. So who has the greater rate? Harrison does. And how do you know? He has a faster or a bigger rate of change. And then think about what it would look like for them for 12 hours. So you know that Harrison's 12-hour information is that he makes 45 signs. So think about what you know is slope and find out what Adam's is. And then if it wants the difference, that means you'll subtract. Okay, so now you have Julie who's filling up a pool in her backyard with the equation y equals 4.5x plus 9,200. And you can use that to show the rate of change. It's the slope. So the slope is 4.5. That's the rate of change. So Julie's pool is filling up 4.5. And then it says y is in water and x is a minute. So 4.5 gallons per minute. And then you have this for Max. So to find his rate of change, how much do your y's change? In this case, it looks like 14.4. How much do your x change? 3. And then find the unit rate. You'll do 14.4 divided by 3. Whoever has the bigger slope, their pool is filling up quicker. Looking at the last page, we have an equation and a graph. So the equation, the weight loss can be modeled by y equals a negative 3x plus 205, where the y is the total weight, x is the number of weeks that he's been working out. And then Drew's is shown in the graph. So Zach gets the equation, Drew has the graph. Well, Zach, it's pretty easy to see his slope is a negative 3 because it's y equals mx plus b, where m is your slope. So Zach is losing 3 pounds per week. So then when you look down here at Drew's, do change in y over change in x. Now you'll see 20, 40, 60, 80, 100. Every one of these grids is 20. So he lost 20 pounds in 1, 2, 3, 4, 5 weeks. So 20, change in y over 5, change in x, simplify it and you get 4. So that means Drew would be losing 4 pounds per week. So think about that as you answer the question, Who is losing weight at a faster rate? Explain your reasoning. And then you'll draw or you'll click over which circle on how you feel about this lesson. Red if you're like, whoa, I need lots of help. Yellow if you're like, I kind of get it. Green if you're good to go. So do that and then let me know if I can help you. Thanks.